The manufacture of wire and wire rope is a complicated process that involves many sophisticated and precise steps. Wire rope starts its life as rod. Incoming rod is checked against diameter and grade. The rod diameter and grade used for any particular wire is dependent on the required wire properties and application. The first step in the manufacturing process is chemical cleaning and coating. The rod is cleaned in hydrochloric acid to remove scale, thoroughly rinsed in water, and then coated with compounds to prevent any further surface deterioration and promote the adhesion of wire drawing lubricant. Wire drawing is accomplished by pulling the rod through a series of tungsten carbide dies. As the diameter of the drawn wire decreases, the tensile strength increases. Depending upon the final required wire diameter and grade, the rod could be drawn to an intermediate size using a ripping machine. The intermediate process wire is tagged with the appropriate information and is then ready for the next step. This identification is part of Bryden American's ISO 9002 quality system and requirement for traceability. Since any drawing process is limited to a specific reduction of area, the intermediate process wire requires heat treatment or patenting to provide the proper steel microstructure so the wire can be drawn to the final diameter. The patented wire is spooled onto formers and the precise specification carefully controlled to meet the tight tolerances of the final product. The patented wire is then tested, and a label is placed on the wire to maintain proper identification. In the final wire drawing process, the patented wire would typically begin with a tensile strength of approximately 175,000 psi. Through the cold drawing process, a reduction of up to 90% is achieved through a series of 9 to 13 dies, giving the finished product a tensile strength from 290,000 to 350,000 psi. To comply with identification and traceability requirements, a label will be attached to the bobbin to uniquely identify the product. New state-of-the-art wire drawing machinery, such as this machine, can now produce wire to a very high tensile strength without the need of intermediate heat treatment. To keep any wire drawing process continuous and efficient, the individual rod coils are welded together. This is a process of heating up the ends of the rod to the required temperature and butt welding one coil to another. Any flash material is removed and the weld is prepared for wire drawing. Finished wire is tested for diameter, tensile strength, and torsional ductility. The information is fed directly from the testing machines into a computer from which a label is produced and attached to the finished wire. The wire is packaged on either spools, reels and formers, or to a customer's special packaging requirement. Upon completion of wire production, the wire is transported to the rope mill and stored in the wire stores, where it's scheduled for rope manufacture. There are several different types of stranding equipment that could be used for this process: bow, planetary, non-conventional, or tubular machines. The type of stranding machine selected is dependent on the number and diameter of wires. Wires coming together at the forming point produce the strand. The entire strand is lubricated in the stranding operation with a lubricant that is specifically selected to provide the best combination of characteristics for the end application of the rope. To produce die-form type products, the wires form through a special tungsten carbide die placed at the forming point. This will give the final rope its special die-form characteristics, such as improved fatigue life and wear. When the core and strands have been completed, the reel containing the IWRC and the bobbins containing the strand are loaded into the closing machine. As with stranding, the type and size of machine is dependent on the diameter and end application of the rope being produced. The rope is manufactured by the strands coming together at the forming point and spun around the core of either an IWRC or fiber rope. Some specialty high-performance ropes require a final operation for completion. Bryden American manufactures a complete range of tiger blue plastic-filled ropes on its extrusion line. These ropes are completely filled with tough and durable thermoplastic that seals in lubricant and keeps out dirt and grit. This helps provide excellent service life for many extremely demanding industrial, construction, and mining applications. Bryden American also operates rotary swaging machines. These machines are used to swage or compact our patented Constructex ropes, which are used for demanding applications, like boom hoist ropes for cranes and drilling lines for the oil field market. A sample of the rope is tested to destruction to ensure that it meets the required specifications, and a test certificate is then issued. After the ropes are manufactured, a warning label and a label identifying a unique rope number are attached to the reel. These ropes are stored in our warehouse or sent directly to a customer. Bryden American has the capability to measure, cut, and coil a master length of rope to the customer's specific requirements. Bryden American also has the capability of fusing and tapering the end of rotation resistance ropes. The rope is heated up to the required temperature and then rotated and pulled apart at the same time to produce the fused and tapered end. This process locks in the special characteristics of rotation resistance ropes.